The second problem I assigned for homework was the Mighty Cable Company manufacturer problem. Again, you can use your calculator on this. We did go over this in class, but I want to just reiterate that it's $120 per meter with a cost production rate of 6 root x dollars per meter. And then it talks about profit being defined as the difference among the money you receive and versus producing. So I like to start with the idea that we talk about profit equaling revenue minus cost. And since this is not labeled in this problem, it's important that you label it. So for part A, the first thing I'm going to do is say, okay, profit is my P of X. And these are let statements. I think you do this in geometry. I'm going to say let P of X equal profit, R of X equal revenue, and C of X equal cost. And so in this case, revenue is going to be $120 per meter. And cost is going to be, what do we have here? 6 root x. Okay. And so part A says, once you define that for the entire problem, you don't have to redefine it. So it's good that you kind of defined it, and now you can use these variables. Find Mighty's profit of the sale of a 25-meter cable. And so what we're looking for here is P of 25 equaling our revenue, which is $120 times 25. Minus the cost to make it. And so we're going to integrate this rate. And that's going to equal $2,500. You could have written it, if you do your let statement, as P of 25 equals R of 25 minus 0 to 25 C of X dx. That would be acceptable as well. This question was worth 3 points. The 3 points coming from using the revenue function, and the answer, including the integral. I believe actually this was another point, but I don't have that document in front of me. All right, part B. Using correct units, explain the meaning of the integral from 25 to 30 of our cost function in the context of the problem. So before you do that, I'd like to just go back for a minute and think about integration is always the difference, right? So I know that if I were to integrate the cost function, right, C of X, and this is just side notes, I know that what I would get like a capital C of 30 minus capital C of 25. And so when I think about what these limits mean, 25 and 30 represent the length of a cord, of Mighty's cords, his cable cords. The cost is the cost to produce them. This is a production cost. So it makes it easier then to write our statement because it gives the difference in producing a 30-meter cord and a 25-meter cord. And so this was only 1 point, just being able to identify what the context actually is. Okay, part C. Part C. Part C says, write an expression involving an integral that represents Mighty's profit on the sale of the cable that is K meters long. So just like in the last problem, now we're writing that profit statement again, but we can use what we have. So P of K equals 120K minus 0 to K, and again, make sure this is a different variable, dx. And there you go. There's your other 2 points. 1, 2. So we're up to 1, 2, 3, 4, 5, 6. All right, 6 points. Part D. Part D, similarly to the problem we just did, says find the maximum profit that Mighty could earn on the sale of one cable. All right, so what again we're looking to do here is figure out where that's going to happen, and so P prime of K is going to equal the derivative, right? We want to find out what that derivative is, 6 root K, and then we want to take that derivative and set it equal to 0. And so we find this, we're going to use our calculator for this, and we're going to get K equals 400. So then we have to just take that value and plug it in. So we need P of 400 equals 120 times 400. Again, you could use revenue here since you define them up top from 0 to 400 of 6 root x dx. And it turns out to be $16,000, and so this is their max profit. There are 3 points here that you can earn. One is the derivative set equal to 0. One is figuring out what the K value is, and then there's one for the answer. All right, that's it for